So this problem proposes the existence of a square with vertices at these points and says that this has undergone two successive transformations to wind up with vertices here. It asks the students to analyze the mapping and determine what those transformations were, and to find a single transformation matrix to achieve that overall result. So the first step I'd expect to see is for students to draw this out, to visualize it. So we would have an initial drawing like this, with A, B, C, D, with C at 1, 1, and drawing its image like this, with points A dash, B dash, C dash, and D dash now with C at minus 3, 3. Now clearly this square has undergone some kind of dilation, so the student might identify an intermediate step here and draw this out like this. Now identify dilate times 3, and now with the points having been moved and reoriented, they need to determine the second transformation, eliminating translation and rotation to conclude that it's been a reflection in the y-axis. So we'll identify that, reflecting y. Other students might identify the opposite order and have an intermediate step like this, with an initial reflection about the y, followed by the scaling now. And A students might identify that both of these sequences are actually possible and wind up with the same image, which, as we know, isn't always the case. Next, we've determined the matrices involved. So this, we'll call it S for scaling. Matrix will look like the identity multiplied by a scalar of 3. And the reflection, I'll call it F for flip. We'll have the x coordinate negated, the y coordinate preserved with these off diagonal elements 0. Now how students come to these matrices kind of depends on their experience. If they've done a lot of exercises involving these individual transformations, they may well be fluent enough to just write them down. Other students may need to do a bit of reasoning about where points move and how their coordinates are affected. And yet other students may have to resort to solving for the elements of the matrices using simultaneous equations. If they were doing that, they could easily go from the first square to the image directly, but they wouldn't be demonstrating their understanding of the mathematical modeling here, merely demonstrating their knowledge and procedures. So we'll follow the A student path through where they've broken these down into individual transformation matrices. At this point, depending on their confidence in determining these, you might see them actually multiply out with vectors for some of the points to confirm that they're ending up in the diagrams as they expect, but that's not critical to the problem, and you may or may not see that. Finally, they need to determine the overall transformation. So in the case where we've dilated first and then reflected, we'll have the S matrix multiplied by the F to the left to compose them. And while we won't do it here, they should come to a matrix like this. And an A student might explore the alternate path as well for completeness and determine SF in this case, where they should come to the same conclusion, which matches the physical reality of these transformations being commutative. So finally, the student should make some written statement to communicate their results, saying something along the lines of the overall transformation matrix would be this one here, which is comprised of a dilation of 3 and a reflection about the y-axis. It'd be great for them to note that the order of these two for this particular scenario don't matter, while acknowledging that that's not always the case with transformations.